All right, so guys, we are live now. People I have joined, and we'll start. It's I guess. Wait, let me check. What's your time? Okay, so it's 1:35 at your time. So I'll just introduce. Hello, everyone. I am Kushal Patel, and I'm just hosting Jason and Daniel right now. So okay. Uh, I'll start with Daniel. So Daniel Yao is currently the engineering director for Yelp Applied Machine Learning, and that is also called AML. So the AML includes the teams working on the company's machine learning platform as well as product-facing ML initiatives, such as personalized recommendation system, revenue optimization models, and integrity signals. Prior to Yelp, Daniel worked on a quantitative trading system and strategies for hedge funds and property trading firms. We have Dr. Jason Sleight. He's currently a group tech a lead on the core ML team at Yelp, where he focuses on the intersection of machine learning and the system engineering. He leads several initiatives to create platforms for ad hoc computing, data ETL, and machine learning, as well as to collaborate with stakeholders across all of Yelp to apply these platforms towards Yelp's business goals. Prior to Yelp, Jason completed his PhD from University of Michigan, studying AI and cooperative multi-agent systems. So the stage is all yours, guys. I'll just be off right now. Okay.
All right, thanks for that introduction, Kushal. Hi everyone, thanks for tuning in. Today, we will be presenting a case study on how we've applied machine learning models here at Yelp to boost sales and operationalized these models through Yelp's data and ML platform. Some intros to start off with. I think Kushal already covered this, but yeah, as he said, I'm Daniel. I'm the engineering director for the Applied ML team, and Jason is the group tech lead for our ML platform. So before we get going, I'll give a quick overview of Yelp. Company's mission is to connect consumers with great local businesses. And of the last full quarter, the company saw the numbers listed here, roughly 100 million monthly unique visitors and actually more than 200 million reviews on the site. These numbers, of course, reflect some impact from the ongoing pandemic. And here is the agenda for the rest of our presentation. I'll talk a bit about our sales account recommendation system. Jason will give an overview of the underlying platform. And I'll zoom back out to mention some of the other applications that our platform supports. All right, so as I mentioned, Yelp's mission is to connect people with great local businesses. Now, in order to achieve that, the company's business model is primarily driven by advertising. I've shown an example of our ads product here where, I did a search for restaurants in Chicago, and you can see that above the search results, there are two sponsored results outlined in red. So the two restaurants in the sponsored section, they are paying advertisers. They each have a fixed monthly budget, and they each pay for ads on a cost per click basis until that monthly budget is fulfilled. Now, in order to reach these local businesses who may want to advertise, Yelp has various sales and marketing channels. The primary one being our local sales channel. Essentially, we have a number of sales reps that call into local businesses to market our ads products. So then the obvious problem here is, there's many millions of businesses or accounts that sales reps can call. How do we figure out who they should contact from this pool? Now, our solution was to develop an ML-driven predictive lifetime value model to assist reps with lead prioritization. Operationally, what this looks like is well, each sales rep is responsible for a certain list of accounts. When a rep starts their day, they log into Salesforce. Salesforce is their primary tool. And they hit a button to get a feed of recommended accounts to pursue. When they click into individual accounts, they'll see this widget displaying the account score with some reasoning behind it. So the score represents our predicted LTV for the account, and it's calculated by decomposing that forecast into a number of signals. So we have different models for conversion likelihood, expected budget level, expected budget fulfillment, and retention likelihood over a number of months. In practice, the middle two terms don't matter too much here, and predicted LTV is mostly determined by the first and last terms. As an aside, we originally only developed a score based on the first term here, conversion likelihood. As you might all know, when you have an ML system optimizing for a narrow objective function, this can lead to unintended consequences. And in our case, we started seeing more sales against lower quality accounts or sort of lower quality advertisers who might be willing to buy our product, but would not see good ad performance and would have poor retention characteristics. So to fix that, we integrated this retention likelihood model utilizing a survival modeling framework with XUBoost. I'm not going to go into the details here, but the purpose of using a survival modeling approach is to allow us to incorporate right sensor data, as in customers that have not churned yet. And this lets us generate retention curve predictions out over many months while still being adaptive to recent conditions. And we displayed some examples on the right here where we generated retention curve predictions for different accounts. So that was a quick overview of one of our ML use cases here at Yelp. I hope it illustrates why these technologies are important to the company. To talk about how we operationalize these types of models, Jason will give an overview of our ML platform.
Thanks, Daniel. Go to the next slide. So when you start thinking about an ML platform or really any technology platform, you kind of have to say, what do you want? And level one is you need to support your client's workflows. If you can't do that, then it's all a waste, right? Go to the next slide. So in my opinion, ML workflows boil down to these four major components. Number one, you've got ad hoc computing. That basically means you write a little bit of code to generate some graphs or tables or something like that. And then you look at those and stare at them, and you write a little bit more code. And you do this over and over and over again. So we call it data science or analytics or something like that, right? As you get a better understanding of what's going on, you start doing more like hardcore data ETL. You take all of your big data from all over everywhere, and you join it together and transform it and smash it, put it other places, and do things like that. Then you train your model, whether that be just a logistic regression or Spark or neural networks or whatever that happens to be. Then you realize your model is wrong for some terrible reason, so you make some more graphs and stare at it, and you iterate and do this whole cycle over and over again until your model is happy enough. Then you have to push it out to production and make all of your ETLs run at real scales and with performance and be efficient, all that stuff. And finally, you retrain your models and do this whole thing forever, right? So at Yelp, our system does all of these different pieces. If you go to the next slide. For ad hoc computing, well, that slide, we got lag. For ad hoc computing, we've settled on Jupyter. So at Yelp, we're running an enterprise deployment of Jupyter Hub, so we can have our users log in securely via SSO, automatically provision whatever server they want with whatever CPUs or GPUs or memory that they need on our internal Kubernetes infrastructure. And then we've heavily customized our Jupyter deployments that have special kernels with specific libraries installed in them and special UIs, extensions to do data discovery, extensions to take the Spark UI and embed it directly inside of Jupyter Hub, extensions to manage your AWS credentials, all of this kind of stuff. And on top of this, we've built a system that we call Folium for archiving our notebooks. And this is basically to let people, view and search and tag and version their notebooks over time so that you can remember what you did in the past, as well as to be able to up and download things and say, oh, I need to share my analysis with someone else. Well, instead of going file, save as, I go file, upload to Folium, and it will persist it on this, tangible server that won't die and go away. Beyond that, we've also integrated Papermill into all of this so that users can create these templated notebooks, and then anyone in the company can go and rerun these notebooks with different parameters. This has been really valuable for like doing experiment analysis results or generating figures for sales reps to make pitches to giant enterprise customers, things like that. All right, so once you have kind of your users' basic workflows supported, level 2 in your platform is enhance those client workflows and make it so that they can do new things in more powerful ways, more robustly, more powerful, things like that. So it probably will not surprise you that Yelp has a lot of data. The level 1 platform for doing data ETL, we're using Spark. So users can provision Spark clusters on demand with whatever CPUs and memory and executors that they need and completely customize everything that they would need to have about Spark. That kind of gives them the raw capabilities. But the level 2 to enhance this is we've built a Python framework that we call Spark ETL, which is a very opinionated way of writing ETL jobs. And by being so opinionated, we can kind of get a lot of code for free and provide built-in implementations for common operations. Like if you want to read data from Redshift or Data Lake, you just specify the query that you want people to run instead of having to decide how do I connect to this cluster and where's the data located and all that kind of stuff. Just write your query and let it go. It also lets you do feature dependency management, so you can break your code down and be more modular so that it's easier to maintain and test, and it did checkpointing and recovery to failure so that if some part of the job crashes, the whole thing doesn't die. All of our output gets automatically schematized and validated prior to publishing things. That way we know that all of the data in our ecosystem is good. We aren't publishing garbage out into the world that other teams might consume and then have weird problems that they don't expect. We just cut that off at the source and don't publish data if it's broken. So level 3 on this is to integrate everything. It's good to provide individual tools that say, oh, you want to do Jupyter? Here's a Jupyter tool. You want to do Spark? Here's a Spark tool. You want to train models? Here's TensorFlow. But it's even better if everything is seamlessly integrated and connected so that people don't ever need to leave the platform. They can do their entire job with one common set of tools. Next slide. So you might remember this slide that I showed just a couple minutes ago. It's a lie, and it's hiding a lot of complexity. And going to the next slide, the one that in particular I want to talk about is on the model platform side, where I had 2 separate boxes for training models and serving models, but that's just a flat out lie, right? These systems absolutely must integrate. And going to the next slide, if they don't integrate, you will have lots of problems. From an ML operations perspective, if you do not have a unified model training and serving system, then it's probably broken and you just don't know about it. This can happen in a lot of different ways. Maybe your feature transforms will be slightly different from the code that you use to train versus test or to make predictions. Maybe you'll have package dependency incompatibilities, then you'll model version mismatches. My personal favorite that we actually encountered at Yelp is that when we were training a model, we used 32-bit floats, and when we made predictions in our real-time system, we were using 64-bit floats, and that ended up making approximately 1 billion incorrect predictions. I'll leave it as an exercise for you to figure out, like, how does that happen, and how does this tiny little difference cause such a huge error? The other thing that will happen is your developer cycle will slow way down, and it takes a lot longer than it should. So obviously dealing with all these tiny little details takes a lot of time. That's why ML ops has become this big field over the last couple of years. And you also end up implementing a lot of things twice. So you get this high interest, technical debt that comes up where now I have to maintain all of my features for my prediction code and my training code. And if they're not exactly the same, then my system's broken and everything crashes. So having it be completely integrated eliminates all these problems. To the next slide. This is kind of how we're approaching this with Yelp's ML platform. We're using Spark as the backbone of all of our training systems. As I've mentioned before, this fully integrates with kind of our data ETL and ad hoc compute things, but it also fully integrates with all of the kind of the ML libraries that we like to use, like Spark ML, XGBoost, TensorFlow, things like that. And then to kind of make the transition and make it seamless between our training and serving layers, we're using MLflow and MLeap, which are both these open source libraries that you can go find. For MLflow, it kind of answers this question of which model was that again? And if you've been doing ML for any amount of time, it's really common that you'll be in a meeting and people will ask, which version is that? Is that the version with the new feature or with the old feature? Or what date rate did you change on and all that stuff? And to answer them, you have to look back through your Jupyter notebooks or your email logs or whatever. MLflow solves this by giving you a unique ID for every single model where we can automatically log all the parameters and metrics and everything else. And then it's crystal clear which model we're talking about. We're talking about ID 123486482, right? On the other side, we're using MLeap to provide model portability. So we can deploy our any ML pipeline, and that includes not only like the XGBoost trees, but also the feature encoding and the feature transformers and that entire pipeline all together as a single unit. And we can deploy that into any execution system that we want, whether that be a microservice or using a REST API or an Apache Flink server to provide a streaming application or whatever. So all of these systems use a common interface layer, and we just tell it what MLflow ID is needed, and will automatically fetch those from the MLflow servers, load them up, and execute them. So this not only allows us to be interchangeable across different execution systems, but it also gives us this abstraction layer so that Spark ML and XGBoost and TensorFlow are all interchangeable. And it provides nice, easy upgrade paths for people as they get more sophisticated in their modeling understanding. It's just an MLflow run ID. I don't care what it represents behind the scenes. It all just kind of integrates seamlessly. So that's the last level, and what you really want in a platform is efficiency, right? If you've been doing ML things, you know that ML is really expensive, not only in terms of like computational requirements, but in terms of developer time. Like owning an ML model is expensive for your team to do. So as a platform engineer, my job is to make that be efficient so that we can use ML in more cases and not be spending all of Yelp's money training like little trivial models. Next slide. One example that we've done this at very recently is for serving our ML models like at scale in real time. So Yelp search results are highly dynamic. There's a lot of contextual features that prevent us from being able to pre-compute all of our results. So we have to score all of these thousands of possible businesses in milliseconds in order to make the page be responsive. And by leveraging our MLeap runtime, we can run our MLeap pipelines directly inside of the Elasticsearch cluster. And instead of having to take the data all the way to the model, we can put the model directly on top of the data. And this means that we don't have to do all the serialization and deserialization costs out of the database, and we can make predictions at 10 microsecond latency per biz, which means that we can score all of our 1,000 businesses in just a couple milliseconds. It makes the page be a lot faster and responsive, and lets them do other crazy things or do more ML models and so on. Next slide. So kind of the last big thing that we've seen by investing in an ML platform is being able to leverage it to do ML in more places. So I'm going to hand it back off to Daniel, who's going to kind of overview some other applications that we've done with our ML stuff at Yelp.
Yeah, as Jason said, we've really been able to build a lot of different applications on top of this platform. And as an example, on the homepage of our app, there's various models backing different components and different widgets on that page. Our ads and search ranking systems, which Jason also just mentioned, these are all integrated onto the same platform. These are collections of classification and learning to rank models. And we also have maybe some less obvious applications like wait time estimates at restaurants, powered by regression models, regression trees built on top of our ML platform. And we're currently in the process of starting to support our various content understanding models, which include deep neural nets for photo and text classification, and the outputs can kind of be combined to make consumer products like popular dish identification. So that's the end of our presentation for today. I hope you all have now have some understanding of how ML is utilized at Yelp and how we've packaged these various technologies to build our internal platform. And yeah, thanks for tuning in, everyone. And reach out to me or Jason if you're interested in learning more. And we'll turn to questions now.
I see a question from Nigel. I'll just say it out loud for people that aren't reading. Does Yelp ML setup in combination of MLflow and NLeap assist you with model interpretation and invalidation for explainability beyond model transfer? The answer is sort of. So what MLflow allows you to do is automatically log all these metrics. So in a lot of cases, what we've built is kind of these common, we'll call it a metric, but it's kind of not, that has to do with, what were the most important features in the model? Like what were the feature importances or the gains or things like that? Or what was the AUC curve look like? What are the calibration plots, things like that. And we're automatically running those kinds of evaluations and logging those graphs to our MLflow servers so that our users can go and look and see what do things look like, and that lets them compare across different versions and different features and different training dates and things like that that they might want to alter. So it does to an extent.
Yeah, I think so. We just have one. Okay, we have one more question. That is, what is your strategy for model monitoring for detecting data, model drift, and monitoring performance?
Yeah, so that is an excellent question. It's incredibly insightful. So this is kind of the biggest gap that I still view in our model platform right now is, what is the monitoring situation look like? Right now, our developers end up doing a little bit of monitoring themselves, or you just retrain the model frequently enough and you kind of don't care that much. If you retrain the model every day, then I don't need to monitor its performance because it's always fresh. But we have plans to integrate our model platform with kind of our experimentation platform at Yelp that we use for doing like A/B tests and things like that. And being able to do kind of automatic ML monitoring and be able to alert people if you have a model that hasn't been retrained in a long time, that its performance has drifted or the features have drifted or things like that, so they can know that they should retrain something. And our hypothesis is that this is kind of a leading indicator on a lot of business metrics, where maybe the ads targeting model AUC has gone down by 2% since it was last retrained, but the number of ad clicks is still going up because of other things that have happened on the site, right? But if we would retrain the model, then we would be able to get that performance back. So it's on our roadmap to work on this year.
Yeah, so yeah, I think so. We have no more questions. So it was a great talk, Jason and Daniel, and we are on time. So thank you so much for your time, and it was really informative. Thank you so much, guys.
Thank you.
All right, thank you.